Yes, in the previous class we discussed the parallelogram. What is the statement for the parallelogram law of forces here? It means if two forces acts the two sides of a parallelogram, then their resultant will be represented in terms of the diagonal of a parallelogram. That is, as we see here, this is one force P. For example, this is second force Q. These two forces represented by the two sides of a parallelogram. This is other side of a parallelogram, and I will complete. Then the resultant of these two forces will be represented in terms of, that is, diagonal here. Okay. Then the resultant force R equal to, just previously I explained here, that is square root of P square plus Q square plus 2PQ cos theta. What is theta here? Theta is angle between Q and P. Angle between Q and P force here. And now let us see one by one condition here, how the P and Q depending upon their nature here. The first condition is, if theta equal to 0. If theta equal to 0, what it mean? This is the theta, right? If theta equal to 0, Q and P lies on the same line. That is, Q and P lies on same line. It means there is no any angle they make. What will be the resultant force at that time? Let us see. Then R equal to, that is P square plus Q square plus 2PQ cos of 0, right? That is cos of, because the theta is 0. Then how we'll get here? That is P square plus Q square plus cos of 0 is 1, right? 2PQ into 1. This will be equal to P square plus Q square plus 2PQ. Okay. This will be equal to, that is P plus Q whole square, right? So finally you will get, this is P plus Q. P plus Q. That is, resultant will be P plus Q. What it tells? That is, if both forces, their angle will be 0, at that time the resultant, what is the resultant? It will be addition of the P plus the force P and force Q here. That is the first condition. Now let us, that is theta equal to 0. Then if you make the second condition is, second condition, if theta equal to 90, if theta equal to 90, what it mean? That is, angle is 90 degree. In between two forces, you will get 90 degree. That is, both P and Q are at right angles, right? At right angles. If both are at 90 degree, then how will be the resultant? What will be the resultant force? Again, you need to substitute in the resultant. That is R equal to, that is, substitute P square plus Q square plus 2PQ into cos of 90, right? Cos of 90 here. This will be equal to P square plus Q square plus cos of 90 is 0. This is 0. This will be equal to square root of P square plus Q square. This is how the resultant force. If both forces P and Q is exactly 90 degree, then its resultant is, that is, square root of P square plus Q square. Okay. This is the second condition. If you go to the third condition here, if theta is 180, if theta equal to 180 degree, what it mean? This Q, it will comes in this direction. Both P and Q, it will makes exactly on the horizontal, but Q is in opposite direction. Q is in opposite direction here. That is, P and Q acts along the same line. P and Q acts along same line. along same line, but in opposite directions, right? This q will comes here, p will go there, line, but in opposite direction, okay. Now again, what will be the resultant if both are in the horizontal? One is here, q is here, p is here, then what will be the resultant? We will see here, that is r equal to, substitute theta equal to 180 there, that is p square plus q square plus 2pq into cos of 180 degree. This will be that is cos of 180, that is, what is cos of 180 here? That is cos of 180 minus 0, that is a sin and cosec are positive but cos is negative here. This is cos of, that is cos 0, this will be equal to how much? Minus 1. This will be equal to minus 1, alright? Cos 0 is minus 1. Therefore, sir, r equal to square root of p square plus q square minus 2pq, right? Minus 2pq. This will be minus 2pq. This will be equal to square root of, what is this? P square plus q square minus 2pq. That is p minus q whole square, right? P minus q whole square. Okay. Now this will be equal to p minus q. This will be equal to p minus q. How is the condition? If p is here, p and q are on the same line, that is theta equal to 180 degree, then the resultant is in the same line, but it will be p minus q. It will be p minus q. That is the thing here. The one more condition is, if p equal to q, that is fourth condition is, if p equal to q, what happens? That is, whatever the magnitude of the p is there, that will be equal to same as that of the magnitude of q. Then how about the resultant force here? That is resultant force equal to, just substitute p equal to q, that is p square plus 2p into p into cos theta, right? Cos theta. This will be equal to 2p square plus 2p square into cos theta, right? This will be equal to 2p square, that is, this is square root here, and here square root 2p square, if you take the common here, that is 1 plus cos theta, right? You know that 1 plus cos theta is, that is 2 cos square theta by 2. Apply this one, 2 cos square theta by 2. Therefore, r equal to 2p into, that is 2 cos square theta by 2. That is square root. This will be equal to, this is p square and here also p square, that is 4p square into cos square theta by 2. Cos square theta by 2, that is square root. How will get totally? This will be equal to, that is 2p into cos theta by 2. That is r. Okay. This is how the fourth condition. If p equal to q, both magnitudes are same, then the resultant will be 2 times p into cos of theta by 2. 2 times p into cos of theta by 2. In this way, you need to change whether theta is 0 or theta is 90, theta is 180, okay, and p equal to q here. In this way, the total 4 conditions we represent like this here. In the first condition, if theta equal to 0, that is q and that is theta equal to 0, you represent like this here. That is p and q, there is no angle here. That is theta equal to 0. Both it will be 0. P and q equal p and q, it will be on the same line. But in the same directions also. At that time, total resultant is p plus q. Whatever you are getting here, p plus q. Okay. The second condition, if theta equal to 90 degree, that is p and q. This p and this q, both it will be 90 degree. At that time, the resultant, how you will find here? Resultant equal to square root of p square plus q square. If 90 is there, square root of p square plus q square here. Okay. In the third condition, if theta is 180 degree, that is here if theta is 180 degree, this is 180 degree. At that time, p in the right side and q is in the left side, but on the same line but opposite direction. In the same line but in the opposite direction. At that time, the r equal to p minus q. That is p minus q here. Okay. The last condition is if p equal to q, the both magnitudes p and q are equal. At that time, the total resultant is 2 times p into cos of theta by 2. Cos of theta by 2. These 4 are the conditions. First condition 0, second condition theta is 90, third condition is 180, and if both magnitudes are equal, what is the condition here? Okay.